Hello Internet. So I'm trying to implement this algorithm that's called Cassowary. It was developed in the late 90s and it is the basis of Apple's auto layout. So people that do iOS development may be familiar with this way of doing layout, but the algorithm itself is it's a mathematical thing. It solves constraints. But this video is about refactoring Cassowary.js, which is this project here, which is a JS implementation of Cassowary based on the original Java implementation. This version is a refactoring of the original of the JavaScript version that was automatically translated from Java. But even this version, I think it's very complicated. So what I'm doing is I'm refactoring the code so that I can understand it better, and I'm trying to make it very simple. I read the papers, the Cassowary papers, and trying to implement from the papers, but I don't think the papers provide enough detail for an implementation. But also the implementation, I think it is too high level. Like it deals with the symbols. It deals with equations as if they were fancy, like high level objects. I want to have an implementation that's more like we organize all the equations in a table and do vector operations on the numbers. But this video is about refactoring code, so simplifying. So you don't have to understand any of this to follow this video. It's just JavaScript refactoring tips along the way. So I already did some work, and like this code uses its own inheritance mechanism. So this inherit thing helper. I already translated some classes to use ECMAScript 6. So JavaScript class constructors and proper inheritance. Like when we do extends like this and call a super instead of calling the constructor like this. And yeah, I did this for many files. I also moved some files. Like I deleted symbolic weight. It is not necessary. We don't need this class. So here, that's how I removed it. Let's see. I moved it to strength. So instead of initializing a symbolic weight here, like this, on the strength class, I just add the value that is the weight itself. It's just a double, real number. Instead of having this, like having a class just to hold the value. This was not as simple as this initially. I also simplified it here. Let's see. Because it was, not even before. Yeah, that's how that constructor looked like. So it had a loop. It was very generic. You could take any number of arguments and did this multiplication like this. But yeah, it was only called like this with 3 numbers. So there's no need to make it this generic. So that's why I removed it like this. Yeah. And turn that constructor into this simple 2 multiplication and sum. Also, another thing that I did is that I removed the computed properties. This is a feature of JavaScript that is I don't think it's very well known, but you can say you can have define a function and prefix it with get, so that it gets you can access it just by doing dot required, like this. So this will actually generate a function call, but it will look like a proper access, normal proper access. So I don't even have replaced it with a function. I just go directly to the strength and ask if the strength is required. So this is a constraint. So constraint.strength is required. So I'm trying to minimize helper functions to get to the core of the algorithm. So I also removed some unused static methods in the expression class. This plus, minus, times. I think since we already have these, I don't think we need this thing. So this is what I think is inefficient. So the expressions, every time you do a transformation in the expression, you actually create another expression. This is very nice. This is a good way to program, because you don't mutate things. You're just creating new values. But as I said, I really want to understand the algorithm and implement it in a more low-level way. Like, I want to. I may want to copy the expressions to a table, but once they are in the table, I want to mutate the table and try to make it more efficient. Okay, so with this introduction, let's go to the editor to start to do more of these tweaks. Yeah, so more about this. Yeah, I already shown this. So this Cassowary.js is used, for example, by this project, AutoLayout.js. They implement the visual format language inspired by Apple's visual format language in JavaScript. So you can do layouts like this and get things laid out like this. But this is a more high level thing. This is a more productized product, like API for the constraint solver. Oh, this is a demo page. So this is built by defining constraints. The constraints here force these two things to be quadrilaterals all the time. So no matter what you do, everything they will always have four sides, and they one will be inside the other, and they kind of move in a interesting way. Like everything, like it tries to leave the points where they start, but it moves them once they have to be moved. Like if I do this. Yeah. So this is in the demo folder. This is the demo. These are the creation of the constraints. This needs more comments to be understood. So let me go through the files again. A thing that this project has a file with redesign notes where he describes some of ideas that he had for improving this. I'm gonna try to implement these ideas. The first thing he discusses here is that variables are created independently of a solver, even though they have to be associated with a solver to make sense. Yeah, well, it's clearly the case that expressions are dependent data types of solvers. This isn't reflected in how they're constructed, however. Because yeah, you construct a variable and they have no knowledge of which solver they belong to. Da-da-da. Also, this comment, further opportunities exist to remove the de-opting polymorphicness in many of the constructors. This polymorphicness he's talking about is like if we go to the expression constructor, for example. Oh, it's still using the old inheritance thing. So, for example, this can be constructed with a single parameter, and it can be a constant or a variable, then a coefficient, then a constant. So expressions will be things like 5 plus, this will be linear expression. So 5 plus 6 times a variable v times 7 times plus 7 times a variable u. So this. And another interesting thing is that you can pass a coefficient. So if you have a single variable like this could be constructed like new expression. The constant is 5. Then yeah, it has to be a var here. You would pass the variable v, then the coefficient of the variable would be 6, and the constant would be 5. But on the other hand, if you're constructing an expression that is just 5, like without any variables, you would pass only 5. I think this is just confusing. We can simplify these constructors a lot if we drop this behavior. So here's where the simplex solver is where the actual algorithm happens. There's a lot of code here. It's very complicated. Let's start from the usage of this thing to get a understanding of how it works, how it can be used. So this is a draggable box. Okay. So I think draggable boxes are these boxes that you can drag here in the demo. So it starts point x, y, and width and height. Let's see how they are constructed. Yeah, there's like, see, this is constructed with a single parameter anyways, which is 0 to 8. Is x even used here? Oh, it is. But why? db. Okay, let's do a db equals this db. I have to do it like this. Can do db dot push midpoints. Also, we don't really need to create this intermediate variable. Let's do just oh no, it's used a lot. Yeah, it's used everywhere. I have to do it like this. This MP equals and MP equal this MP. What is this? Okay, let's understand why this a parameter, I mean, this can be called x to make more sense, because it's x here. The width can be 15. We are not we're not considering these arguments anyway. This is the HTML file. Yeah, it doesn't do anything with this. Yeah, why will be always null. I don't know why it's even here. So what's the point constructor? It's a suffix, xy suffix. Okay. This is so wrong. This is a string. let's just delete this, because y will always be null anyway, and let's call this suffix. This is a suffix for the name of the variables that are inside the pointer. And yeah, we can, yeah, it's okay. We can call it I. Makes more sense. Also, let's use let to make it restricted to the local scope. Same for A. Are we using A anywhere else? Yeah, we're declaring it again here. It's another function. So here we're creating this draggable box. Yeah, let's test this. Yeah, still works. So all that code is, all this code is unnecessary. Can just be this. Center. Yeah, this center, get center, center is just, I mean, why this cannot simply be center equals v? Let's see how it's used here. Oh yeah, because it wants to preserve the suffix. So yeah, I'm setting the xy of the point. Is that simpler though? And this can be, make a macro for this. This could simply be center.x equals 10 center.y equals 10 and I don't mind this. I'm gonna rename this variable to not have the underscore prefix. Center used anywhere else? No. Yeah, that's the only place where center is considered in the usage code. So we can get rid of this, get rid of this, and then we can replace center underscore center with center. Yeah. Okay, so this get x and get y, yeah, it's very nice to use it like this. I think I can leave it like this. I'll make it more. I don't mind long code. It's easier to read. Draw. Oh yeah, this is interesting. This is the code that draws the draggable boxes. These boxes you see here. Okay, let's. Oh, we added some. Created a bug. No, did we? Yeah, there's something wrong. They didn't start like that. What did we do? Probably messed up with the numbers here. 10, 10, 10, 200. You know what? There's a even better way to set that. We can create a function called setCenter that takes x, y, and it does this center x equals x. So we can do, let's do it like this. Set center. Can you get it from here? My macro failed. Anyway, okay, let's do it manually. It's not a lot of work. Set center 10 to 100. Set center to 120. Whoops. It should be 2. Oh my god, I'm lost. Yeah, I'm completely lost here now. I try to automate this. Yeah, let's do this with a macro. Set center. Right. Why did it not work? Yeah, it is your problem. Let's analyze the diff and see what's the problem with this. Set center. Yeah, if there was a problem, it was actually probably here in the numbers. 10, 10, 10, 200. Oh yeah, that's the problem right here. It should be 200, 200, and 210. That makes more sense. Yeah, it works. No bugs. Okay, let's see. This contains what? Where is this function called? Oh yeah, this is to check if a point is contained in the box for the heat test. This makes sense. confusing things. This X. Oh yeah. Oh yeah. So this is confusing. Oh my god. Let's not use this X here. Let's use a center X. Let's be more verbose, but make it more understandable. Wait, we can do it. Yeah, X. These two values won't change. So X equals this center dot X, and Y equals this center dot Y. Then we can. Oh, but yeah, but X and Y are what's already being passed there. Okay, so center X becomes X. What? Yeah, so this X. Even better, we can do like this. I don't know why it accepts a value. That's weird. It has a value field. Yeah, let's look at the point class. Oh yeah. Oh yeah. So when you set a Y in the point class, it is actually creating a variable and setting the value to that value that it will pass. So that's why. But when you read a variable. You don't read the value. That's weird. But yeah, let's. Now it's, yeah, that's why we set it like this, but we read it like this by getting the value. I don't have to get the value here. Yeah, this is magic things are complicated. We can also rename these. So this can become W and H. Oh, I think this is easier to understand, even though it's more verbose here. Soon we won't even need these getters. Oh, we use them here. Yeah, we use them to construct the expressions. Oh my god. String. What is SX? We never set SX. The toString function is broken. Let's see what happens if we delete it. Nothing. No error. Because it was broken anyway. Should probably commit some of these changes. What's the message? Will be draggable box simplify draggable box. We also have tests, but the tests do not yarn test output. No, npm run test. The tests, I don't think the tests cover the quadrilaterals demo. But yeah, all tests are passing. Ignore these errors in the beginning. This is just the old Springma parser is not able to parse modern JavaScript, but we don't care about that. But yeah, the quad demo is working even with all our changes. Okay, here we can also do the same thing we did here in the drawing. So this will be X. I can drop this. This can be W, Y. Yep, then it fits in a single line because X, Y is the center. So you draw a rectangle with this passing the origin X, Y, and the width and the height of the rectangle that you're trying to draw. That's nice. Set center. Okay, this get. This is confusing. Like X is a variable, it's not just a value. Getting it just as X is so confusing in the user code. Another thing, I don't think we need just set center. We can pass it in the constructor. Yeah. So we can do it like this. This will make much more sense. So this is X, and this is Y. Let's start like so we can change set center. Yeah, we can. We're gonna do it like this. We're gonna do db. Let's do it. New draggable box. Why 8? Why do we create 8 draggable boxes, even though we only use 4 of them? That's weird. No. Yeah, let's no, we can deal with that later. So instead of the loop, we're gonna have like things like this: db push new draggable box 10 10 and a string 0. Then we're gonna have 10 200 1. I have 200 200 2 2, 210, 3. See if it were, oops, broken, cannot read property X of undefined. What? Oh, the MPs. Oh, that's where they use the... That's so weird. So the MPs that are the midpoints are also draggable boxes. Oh, so those are this... too bad I can't show it here. So the draggable boxes that are in the middle of the segments. Okay, we can fix this. Yeah, we can do more. This will be 4, 5, 6, and 7. Yeah, now it works. But this is so convoluted because what we can do instead is we can push this to the midpoints. So this would be like this. We don't need this. Oops, we're failing to draw them. I think I know why. Yeah, when do we call draw? Yeah, DBA draw. Yeah, it makes sense to have all the draggable boxes in an array. Okay, so let's put all the draggable boxes here. But then let's make MP equals db4, db5, db6, db7. It's just a line. It's even simpler than a loop, you see? And we don't have to this MP equals, these are the midpoints. I think I'll make it like this so that it makes more sense. Same here. Midpoints equals midpoints. No, I don't want to test anything. I want to test here. It's working. It's working as expected, I think. Yeah. So this add point stays function is, what is it doing? It's in the solver add point. So for each point that you pass, it adds a stay. What? Yeah, I don't, this function is weird. I don't think this function belongs in the solver. It's like, I will inline it, because it's specific for this kind of problem where you have points and it's not a very general function. Oh, it's adding stays for the... Okay, so it touches only the first 4 draggable boxes because they are the last to move. So see, look at this draggable box here. It doesn't move, you see? It only moves when it has to, so that the other constraints are not violated. So that's what stay means. I think we can have another array that is the corners. So I would say corners db0, db1, db2, db3. Then instead of, so here, so I could change it to be corners. Let's comment this out. Yep, so everything would still work. And now we have an array for the corners. So instead of having this function, I will do, oh, but what did it do? Oh, it passes the center. Interesting that it probably didn't work. Or I don't know. But anyway, let's do corners for each, and then a point will be the corner. The point is the center of the corner. Yeah, so we add a weak constraint to maintain that thing in there. You can call it C for center. Yeah, then we can remove this. MP stat. I don't think having this thing called MP is helping anyone really. Let's replace all the NPs with midpoints. No, oh yeah, that's completely wrong. Yeah, midpoints makes more sense. Bro, oh yeah, weak is not defined. Because weak is a C strength weak. C strength weak. What? Cannot read proper weak of undefined. What? Because we don't have C or what? You need to have access to C dot. Oh, because I included the strength. Where is the strength? C strength equals strength. What? So C, what does C contains? Why does it contain expression, or it does not contain strength? It does contain strength. What? Oh, look. Jesus Christ, that's a bug. Yeah, because I redefined C here. Oh no, it should be center. Center. And it will work. Can remove the breakpoints. Oh yeah, this add state. Yeah, this is wrong. Should be solver. Yep. How it works. So if we go to the Simplex solver, what was the name of the function? Stays. Yeah, add point stays. Is it used anywhere else? No. We can delete it. We can also delete it from the tests. Look, the function has no tests. Yeah, that's a sign that the function is not that useful. And we're testing it here. This code is now tested because we tested manually. I mean, we can later refactor this to make the code testable, but we're testing it manually, and we're checking that the corners they can't be easily moved. They tend to stay where they are. What's this? Yeah, so here we go, creating more expression, creating the actual constraints to keep the midpoints at line midpoints. So these constraints are to maintain these midpoints between these 2 points. So CLE is the expression. I think it should be called expression. Yeah. Also, this equation. This can be equation, or inequation. I want it to be. What's the name of a thing that means equation and inequation at the same time? Like equation, inequality, equality, row. Nah, let's call it EQU. It's better than a CLE. Kill. Yeah, done. Let's test. Everything is working. Let's commit. Let's see the diff. Yep. So let's add demos, source, and tests. More quad demo simplification. I will squash these commits later. So see, we deleted 100 lines and inserted 83 lines. Line count and I removed the loop. So this used to be inside a loop. I removed it, and we still get to drop a few lines. And that's a interesting thing, because sometimes you do some transformations while refactoring that seem like are going to increase the line count, but then everything gets so simple that you can delete code that didn't make any sense before. Okay, so back to these expressions. So let me try to explain what's happening here. So to keep the midpoints at line midpoints. Okay, so for the DB, the draggable boxes from 0 from index 0 to index 3, they are the corners. So what we can do is we can rename this to corners. I think it's all of them, because yeah, all right. Everything works. I think I should commit this, because if we break something, I'll just demand. If we break something, it will be easy to see where we failed. I don't like this C dot expression thing. Eventually I will remove this C global C object. So what I'll do here I'll do const expression equals c dot expression, and also for equation. So now we can replace them all. We can replace c dot expression with expression. What? Yeah. And c dot equation with equation. Let's test. We broke something. What? Unexpected identifier. Oh, I deleted the brace from here. Everything works. Again, let's add demos and commit. All right. So what's happening here is that we want to add this, the constraint. So the equation says midpoints 0 x is equal to that expression. That expression is what is that? Okay, that expression is 1.0 times corners 0. We have to look at the expression constructor. Remember that I said that constructor is complicated. It's supposed to be useful, but it just complicates things. So it's then plus corners 1 x. So this is also, we can drop the 1.0 because, and then it's divided by 2, so it's 0.5 times 0.5 times corners x. I think there's a simpler way to create this these equations and expressions than this to get this. Can we maybe the conversion to string does a good job. One can only hope. Yeah, see? Let's see. So let's compare to what I derived here. What 5 times 10? 10. What's 10? These are variable codes. So half plus the 10th variable. That does not make sense. Does not make sense at all. So let's go to equation. Equation class is in the expression file. What? Where is it? Maybe in the constraint file. Equation. Let's find the toString. Okay, toString LC. LC is a constraint. Constraint toString. There's the toString here. So it's a weight. converts the weight. So yeah, 1 is the weight. Then it converts the expression. So the expression to string is what matters. Needs what's this? Oh, v. V is the variable. But times v. But then it's getting converted into a number. Let's see. Okay, let's see variable. Choose string. This prefix plus this name. What? That does not make sense. Is this a thing? Yeah, this is very weird. This is not what we're getting there. I think I need to debug this code. So let's open constraint. Yeah, let's put a breakpoint here. Run it. Yes, so we can get this is the first step. That is converting the weight. And now we get to the expression to string. That's what matters. So let's play a little with the variables here. The constant is 0, which is weird. This is constant. Is this a constant? No, it's not an expression. Okay, so it's not a constant, so it goes to convert the terms. Terms is a hash table. Dot store. All right. So we have these entries. Key 12. That's so complicated. Okay, so the value is a variable. Yeah, the value is half. So this variable should be, the name is x0. I want to see x0 there. Let's put a breakpoint there. Oh yeah, value of. Okay, then we got our fix. We should call toString explicitly here. Where is this? This is expression, right? Yeah, so let's do toString. Let's see if it works. Yeah, now it's calling the right function. It's calling the toString that we were looking at. So yeah, so it says half times x0. This 10, what is this 10? We should go to the variable. So 10, so the prefix, the name, and the value. So the current value is 10. Oh yeah, this is the initial values that we give to the this is 10, this is 200 for the x. Okay, so x0, x1. So our equation, let's see, let me close this, close this, close this, close this. If we go back to quad demo, our equation said this. Yes, don't think that's what's going on here. Oh yeah, it makes sense. Yeah. So if we transform this equation in, if we move this term, if we move, if we do it like this, 0 equals, so this becomes negative, and let's delete this because this is invalid now. That's the equation. Let me also move this 0 to the end. So this is more directly, it's a more direct representation of what we created here with these complicated constructors, and this is what internally this equation was turned into. So when we had this, saying this was equals that. Yeah, we do the equation here in the end to equate this variable with that expression. So this variable is equals this expression, which is corner 0x plus corner 1x divided by 2, which is like half times those two x's. And yeah, and then we can internally move this midpoint 0x to the other side of the equation, so it becomes negative. So this is x4. This x4 here is this midpoint 0. So we can move it to the end to make it clearer. Put a plus p. So plus minus. This is not good debugging code. So here we can have a mapping of our variables. Good. So I think the way I would like to create this equation is I like to create new constraint row. Let's call it inequality. And then I can pass equality operator. I would pass the left hand side. It would be midpoints 0 dot x that equals the expression, and the expression would be an array of coefficients and variables. These would be in pairs like this. So I would pass corners 0 dot x, and then I would pass 0.5 again, corners 1 dot x. Is that the best we can do? Probably. So this would be easier to turn into this expression than these two lines here. I don't know. This is a thing for another time. So it does similar things here. So yeah, these are the constraints to keep the midpoints at line endpoints. Yeah, because half of the corners x plus half of the corners 1x minus the midpoint x is equals 0. That's an interesting way to express that. Yeah, so let's put it like this. Since these are related. Plus C plus. Inequalities. These what are these new constraints doing? Let's make it like this. What is this thing? Let's translate the first two constraints. So the first one is an inequality. Expressions. So the expression is corners 0 times x plus 20 less than or equal corners 2 dot x. Yeah, we should be able to yeah, let's do const no, we don't. No, we can do EQ and I can do console log choose string. I can add it like this. Same thing here. EQU equals this. Can add it here. All right. Getting a lot of stuff here. So here this can become this. This can be removed. Okay. So how do we turn? Can we turn this expression into this actual thing that is there? So first thing, we should invert this. So 0 and minus 20. Okay, so minus 20, if we move it to here, it becomes 20. You can drop the 0. And I would say that corner 0 of corner 0x is of course x0. It's the first variable we create, and yeah, and x2 is corners 2x. Yeah, so our understanding of this inequality constructors and plus and blah 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 is accurate. Again, I don't like how we create these inequations. I will come up with a better way later. Ideally, you would have a language, you would parse, like that's what this outer layout thing is all about. You create constraints like this, and then it takes care of creating it parses this and takes care of creating other constraints that positions these elements in the page like this. Here, yeah, we can change this to arrow functions. Then we don't have to pass this. Yeah, these constraints, I wish this code was commented out to actually have all the constraints in a nicer way, but anyways. If event yeah, just renaming variables. Oops, no, this is this can be better written like this. Again and again. Should have committed those changes. So yeah, let me commit this. I'm done for the day. Let's just commit the constraint code. This is a good chance to review what we did. This is a mess full of comments, but that's okay for now. Yeah, this is, I don't want to add this now. This is just using arrow functions. Oh, this is an interesting, this deserves its own commit because it's a fix for v to be rendered as the correctly. Debug. Let's say check constraint expressions. This is use arrow functions. Use arrow functions. And this is the most important commit. This is the fix. Fix expression to string to render variables correctly. Yes. So let's recap what we did today. We simplified we understood the draggable box. Its constructor took 4 parameters. It now only takes 1. And we removed these loops. And we removed them later. Here. Yeah. I did things like this. We renamed, like, instead of referring to the corners as the B0 until 3, we call them corners. Just like we call the other draggable boxes midpoints. So, and then we inline the add point stays function to because we don't think it, I don't think it belongs in the solver. It's a very specific to this quadrilaterals demo thing. Then we understood, we tried to derive the expressions that were generated by these expressions, and using the debugger, it was interesting. We even fixed the bug. Like, we now convert expressions to string correctly by converting the variables to strings correctly. All right, I am done. If you like this video, this kind of things, come to this channel more, subscribe maybe.